Good day, everyone. We hope that everyone is safe and well during this pandemic. Today, we will be talking about a very interesting topic, the underground space planning for Manila, case studies from various cities and countries all over the world. As you all know, space, both above ground and below ground, can be really tight in Manila. With the upcoming major tunneling infrastructure projects in the Philippines, I believe that this is indeed a subject that we can be applying in the near future. I see that we're still waiting for a few more attendees to join in, so please sit back, relax, and see you in a bit. Good day, everyone. We'll be starting shortly. Today, we'll be having a well-known figure in the industry talk about underground space planning for Manila, case studies from various cities and countries around the world. Before we begin, a few house rules and reminders for our attendees. As this is a webinar-style Zoom, the attendees will not be allowed to turn on their microphones. However, please feel free to ask a question in the chat room, and we'll be having a Q&A session with our speaker after his presentation. This virtual event is being recorded and it will be shared with everyone after the event. We will also be posting them on our Facebook, LinkedIn, YouTube, and website, failtunnel.com. Finally, after the program, a group picture will be taken for all the attendees in this virtual event. So please don't leave right away. Now, to start our program, let me give the floor to the Treasurer of the Philippine Tunneling Society, Malcolm Lorimer.
Yeah, thank you, Lance. Good afternoon, everybody. Good afternoon, members and guests. I'd like to start, if I could, by just giving a short update and a little bit of an overview of our current situation with the number of with the membership here. Lance, would it be possible for you to flash up on the screen the corporate sponsors? We'd like, and corporate members and individual members. We would like very much at this point to thank everybody who's supported the Philippine Tunneling Society and become corporate sponsors, members and individual members. And looking ahead to 2022, we have an exciting program ready for you, and we are also quite keen that we should enhance and bring in new members. So it's very important that we spread the word and get the message out there so that we continue to support this growing society. I'm also just pleased to announce, before I introduce our speaker this evening, Mark, to confirm to everybody that we have just held our annual general meeting for 2020, and we have approved the financials for 2020 and appointed directors and officers going forward for the Philippine Tunneling Society. With that, I'd also like just to introduce, if I could just flip to the other slide presentation, please, Lance. With that, I'd like to introduce our speaker for this evening. We have with us, we're very lucky to have our president, Mark Wallace, who has over 33 years of experience in the field of engineering, geology, geotechnical, underground space, and tunneling related projects. Mark has carried out project management on various infrastructure projects, from large scale MTRs in Hong Kong as a Philippine government projects, as well as local, private, as well as regional scale studies. Mark has and continues to lead teams of specialists in tunneling, civil engineering, renewable energy, engineering geology, geographic information systems, and geotechnical work in Hong Kong, the Philippines, and the East Asia region. Mark was the project manager for the territory-wide study on the urban underground space in Hong Kong, as well as the long-term strategy for rock cavern development in Hong Kong. These projects sought to identify strategies, approaches, policy initiatives to facilitate further underground space development, to provide a sustainable source of land supply, and while also providing better connectivity and improved amenities in existing areas of the city. Mark, our speaker, has authored and co-authored 20 publications with topics ranging from rock cavern development, urban underground space, tunneling projects, landslides, to GIS-related solutions. I'm absolutely delighted to introduce our speaker for today, the Director of Infrastructure for Arab Hong Kong and the Philippines, Mark Wallace. Over to you, Mark.
Thank you, Malcolm, for that nice introduction. Thank you very much. Let me just share my screen. Here we go, share. Can that be seen? Can you see that?
Hi, Mark. Yeah, we can see all of your slides.
Okay, there you go.
There, yeah, you can see your presentation.
You can see my face. Excellent. Okay. All right. Well, today, this evening, I'd like to, ladies and gentlemen, sort of run through some underground space planning sort of reviews that we did for the projects that we did in Hong Kong and also in Singapore. So I want to just give you a flavor of the different strategies that have been done for underground space planning in other cities and countries around the world. So I have to put a legal disclaimer in first and say that I'm not a lawyer, right? So some of this information that I'm going to present has been a few years ago, but should be still current, most of it. And I have to give credit to a law firm that helped us in Hong Kong when we were doing some of the materials about the legal aspects of land supply and underground space in Hong Kong. So tonight I'm going to run through these aspects, planning and underground attributes. So this is the sort of subject matter that I'm going to go through, and then hopefully at the end run through some sort of insights or conclusions from my brief period in time in the Philippines, how maybe there could be better planning that could be put in place for some of the upcoming metro systems and underground metro systems that are being implemented in the city. What are we talking about? So, underground and the how we use the underground is a problem, that we've been recognized for a long time, actually. So in the 1914, the chief engineer in Philadelphia recognized that there was little thought that's been given to the subterranean streets, and then only a very few of our large cities has any attempt been made to plan the subterranean streets or to chart the structures which they contain. So these is talking about really utilities and all the things that go in it, right? And this is a photograph from Wall Street in 1917, and you can see this is exactly the same that you see in the ground in many, many cities around the world. Manila obviously has a lot of this above ground, where you see the cables and so on, but underground you see all of the pipes and networks and so on that crisscross. It's obviously needs to be managed and understood really quite well. So as we progress through our urban growth, as we've gone from the 1800s up till now, there's been a transition of different types of things. So foundations have progressed through shallow foundations, wooden piles, caissons, Frankie piles that were in vogue in the mid 60s and 70s, barrettes, mini piles, and so on. So as we've done that, we tend to find that these piles and these foundations go deeper. We also tend to find that they're supporting heavier structures. And in addition to that, the congestion of all of the other supporting infrastructure, such as sewage, water pipes, and utilities, is also tending to get deeper. And that's just the function of these systems all being on top of each other and being congested. So what is it with the underground that we like to have? It provides space. So these are the attributes that really people think about when they're thinking about the underground. So it provides space for activities and things to go that service our cities. It provides protection where we need it. So it can provide mechanical, thermal, acoustic protection from things that go in the ground, and removes those sort of impacts from wind, from blasts and other things. It provides containment, so it can be used as a secure place to put things, and also protect us from the impacts of any particular dangerous facility. So if it was an underground magazine, for example, it obviously reduces the impact of blast and so on. And then it also provides low visual impact. So when you go to BGC, you see that most of the utilities are underground. So all of the overhead cables are now hidden below ground. Provides stable environment. So typically, and when we talk about sustainability these days, we talk about the sort of use of energy and so on. And when you look at the ground, typically within the top 10 meters, the average annual temperature is the temperature that the ground or the soil and the rock generally will have. And it has some low thermal conductivity properties that are sometimes useful. But some of the other attributes of the underground is that it has the psychology of underground. You feel worried when you go underground. And people think that it's not so safe, and it can have health problems because of air quality and so on. But certainly in Hong Kong, where I am just now, many millions of people travel on the underground through the metro systems, and they don't really appreciate it because it becomes part and parcel of the work and the lifestyle that you have in cities. And that's what's going to happen in Manila soon. when the metro systems come and people will get used to going and traveling on the underground. There are other problems for emergencies and escapes. So, you know, when there was an emergency with the sarin gas attack in Japan in Tokyo, and how to get people out, how to do that safely and so on. And then confined space can have that benefit and also have the constraints such as the evacuation and getting out of the ground. But there's also problems where we have the underground and we have to have the entry into the ground. So portals, how do we get entry into the ground? We have other aspects of construction, subsidence, groundwater drawdown, and then the type of geology and how easy is it that we can build the undergrounds through the pipelines or the basements in the cities that we have. And the underground environment also needs protection in these dense urban areas. So if we want to use this corridor for a tunnel or a pipeline or whatever, maybe we need to protect that in some way. And then obviously the economics of the whole question of going underground, it does cost more and it does have an impact in terms of how you can use it for development. So what are we talking about when it comes to types of underground space? So back in the 1960s and 1970s, and maybe even earlier than that, in the 50s, there was this sort of urbanism that had this vision that we would all be living underground and sleeping underground and have residential underground. And this sort of came out of the Paris sort of urban ideas, and the French were architects and so on were quite keen in trying to push this forward. And many of these sort of integrated urban underground schemes were put forward to try to connect in with the metro systems in France and other cities around the world. So there's different types of underground space that we typically talk about. So we have basements, and we know that in Manila, in particular, there are really quite deep basements. And some of the questions, I suppose, is are these used as effectively as it could be? There's pipes, cut and cover tunnels, bored tunnels, mechanized tunnels, shafts, and so on, as well as caverns. But there's also natural caves that you can also get in urban areas. So these are the typical things that we think about when we consider about underground space. So these are really cool. These are photographs that come from Stockholm Metro. And this is the underground metro system, which lies in rock, and these are rock caverns, but you know, you can create really quite cool underground spaces for metro systems. And this is a great example, I think, on how you can form these spaces and how you can make them look nice and usable. And then you get these sort of functional metro stations. So this is Milan Metro, Venezia station. And you can see here the actual support that's put into the soft ground excavations for this particular station that form a sort of architectural and aesthetics that really looks quite nice. So again, you know, the functional aspects of how you build it, you can incorporate into the space that you create. And then in Russia and Moscow and the metro systems there, they've gone for the Gothic sort of look. And it's the same on the St. Petersburg metros as well. And some of those metros are very deep because they're combined into civil defense shelters for the public. So again, some of these stations and these underground spaces can be quite ornate and quite elegant. And then also you have pedestrian subway networks, and increasingly these days people are starting to put in these sort of LEDs and making these underground spaces look quite bright and welcoming. And some places they're becoming attractions, such as in Taiwan and Taipei. There's an underground dome of light that also attracts people as a tourist attraction. So in particular in Hong Kong, we have some networks such as here, but connecting between East Tsim Sha Tsui Station and Tsim Sha Tsui Station. Very sort of more functional type of spaces where it's just a flow of pedestrians and people from one station to another. But there's also connections into adjacent retail. So some local shops and developments have access directly into the network to allow people to be attracted into their shops and spend more money. So when we think about the underground, we should also think about, whenever we're looking at the cities that we're in, what's the geology, what's the type of surface development, and how it interacts. So when we build the tunnel, we see where it hits certain features that are of concern. So mixed ground. So at the start of the tunnel, when it goes into the rock, it's quite likely that there'll be slow, maybe some more face loss and more settlement. So where we see certain types of ground conditions, such as the marine deposit shown there on the left, maybe there's more likelihood of settlement and distress on the buildings, and some of the piles might become problematic. And then similarly, where you have buildings that are very shallow, if there's drawdown of groundwater, that can have impacts on it. So whenever we talk about the underground, we have to always think about the type of ground that we go through, as well as the impacts that we have, and what that has as an effect on the existing buildings and facilities that are around underneath these tunnels. And obviously, we don't want this to happen. So this is when underground starts to get a bad press. So these are some failures that have occurred as a result of tunneling or deep basements or deep excavations. And this is what we want to avoid, but sometimes these things happen, unfortunately. But you know, we try to get lessons learned from these and try not to make sure that these happen again. So in the studies that I've done in Hong Kong, we were really looking at two types of underground space. So we were looking at rock caverns, and we were also looking at urban underground space. So Hong Kong has a sort of unique side to it because it has very high property land values, it has steep terrain, it has urban sort of areas that extend up into the hillsides. So the challenge here was with Hong Kong government to try to see how we can utilize some of these underground spaces and utilize the hard rock mountain areas to transfer existing government facilities underground, and then use them for land sale to get additional areas to develop. And then the challenge for the urban underground was to see how we can reuse or utilize local areas within the urban settings, such as parks and so on, build underneath it, then reinstate the parks, and then utilize that for more creative uses, such as clinics and sports centers and so on. So typically, these are the types of underground space applications that we have in Hong Kong. So we have retail in basements, car parks, and we have connectivity through pedestrians, road and rail networks, as well as other types of flood prevention, retention tanks. We've got tunnels that take away surface water from the hillsides, utility tunnels, cable tunnels, as well as underground water treatment and sewage treatment and service reservoirs. So in Hong Kong, we have one of the sort of land ownership issues that we have is that when somebody owns the land or has a lease on the land, they own the underground to the core, and they own the airspace above their property all the way into the stars. But there's also some specific ordinances that are have been enacted, such as the sewage tunnels statutory easement ordinances, as well as the mass transit land resumption and related provisions ordinances. So the city has controlled how it preserves and how it maintains the aspect of ownership and provisions for safe access and safe operation of these utilities and infrastructure that are placed in the underground. So it tends to track it. This is a sort of screenshot from the town planning board in Hong Kong, where there's a digital register of all the different land uses from the statutory plans that are found in Hong Kong. So you can go on the website and you can see what uses are there, and when you click on these polygons, you get a display of what are the permitted uses that they have within them, and these can be allowed to be underground or above ground. And one of the outputs from our study was to look at how we can try to identify places on the hillsides that I mentioned earlier, where we could put strategic cavern areas. So these are areas where caverns could be put into the hillside so that existing government facilities could be relocated. So we developed this cavern master plan, which is one of the first in the world, to strategically identify government facilities that were suitable to put into underground spaces to be transferred underground. So it had to be planned in such a way that it had good connectivity, it had portals, could be able to be entered into the ground, and the rock and the geology was generally good enough for that to be done around the city. So Hong Kong itself, through those studies, they were looking at there's a set of standard Hong Kong standards and planning standards and guidelines that are used by the planning department to control and to identify what can be built in terms of the planning of the city. So one of those was to look at the sort of examples around the world of what gets put underground, and then the HKPSG was to be updated and include other types of land uses that we know that can be put underground, and then prepare some guidelines and some standards to be able to effectively place them into the hillsides in Hong Kong. Other examples that we've identified through these previous studies overseas usually relate to what sort of land ownership is, right? So we've done these studies and we've looked at the the different type of legal frameworks that usually get applied. And here, this is in many countries around the world, common law approach usually means that whoever owns the land also owns the airspace above the land and everything beneath it. So the same way that I showed earlier about Hong Kong, you own everything up to the stars and everything down into the bowels of the earth. There are usually three notable exceptions to that. One is that the minerals and mining rights of minerals that are below your property are owned by government, and usually coins, bullions, and trophies, as well as antiquities, will usually be owned or have some value to government or to historians in the countries or the cities that you're operating. In terms of land ownership, usually through those underground limits, these are the cities: London, Paris, Seoul, Taipei, Australia, and so on. Usually the common law countries that have this sort of ownership, which you can see there on the right, so to the bowels of the earth and so on. So usually in those places, you need some form of legal recourse to occupy the spaces between the public land that goes through the private land. And in particular in China, for example, with the state-owned land, you usually get a lease, or a lease is provided to occupy those spaces. So in UK, when you're thinking about the underground and land ownership, if you're trying to develop somewhere, there's certain control measures that are usually imposed. So through legislation, there's a land use planning that usually controls the type of spaces and development that goes above ground and below ground. And when you look at building control, when you're looking at underground, you usually have to ensure that you have good control. You don't have a major impact on adjacent structures when you're looking at doing anything below ground. And then you have controls through health and safety provisions for workers and so on in confined spaces and so on during construction. And then the usual sort of environmental protection measures that usually get applied when you're thinking about doing underground spaces and so on. And in particular, some of the parts of London, for example, have this phenomena called Iceberg Houses. So where you get, and again, because of height restrictions, so this is a time where, because of restrictions on building up, people have tended to exploit the underground by extending their properties below ground. And because of many problems that occurred because people have done them badly or bad design, many councils in these areas, especially in London, have a requirement to do a basement impact assessment, where you have to do all of these things shown in the bullet point about how you assess how you can construct it safely. You're not going to impose any changes on adjacent areas and so on. You do flood risk assessments and how you're going to get rid of the soil material and so on. But in some places, these iceberg houses, they're a significant amount of, there's more GFA underground than there is above ground. Another example was in Australia, where the city of Sydney was looking at doing an underground master plan, and that was being put forward. But this is more about a case of whether you have an advocate. So you have people who are interested in making sure that this is controlled properly, and you have a vision of how you take it forward. And in this case, this sort of initiative lost momentum because there was changes of key personnel and so on in the city. But since then, there's been many underground projects that have been constructed, even though this wasn't there, but maybe they could have been done better if this had been put forward. So other cities around the world have got different types of plans. Beijing has an underground master plan based upon an accessibility aspect. So it's about how easy it is to do things within certain depths, right? So they have some criteria that they have, and they are linking their above ground with their below ground master plans. And they use a depth sort of approach. In the same way, Shanghai has done the same thing. So the top 15 meters is considered to be easily accessible. And then as you go deeper, there's a layering of the different aspects of the infrastructure that support the city that then are utilized at different levels. And usually the deepest level is the level at which you want to have limited access and less people going to, and it's really for the most significant sort of infrastructure that's going to be put in place. And in the Netherlands, in a few cities in Antwerp and so on, they have a layering approach, which is all similar. So it's a very common theme that we have around the world of people saying there's a top layer, there's the occupation layer, there's the network layer. So in Holland, they consider there's infrastructure would go in the second level down. But in this case, they also look about the preservation of the water supply and the resources of the water. So the underground that they put there is about preservation of that, because they use it for water supply and they use it for those other things to do with boreholes and wells and so on. And another thing in China, there has been a drive in the recent past to do a lot of underground developments, and the government has had many initiatives to push these forward, and they've been allowing the developers to have the underground space as free GFA. So, you know, who wouldn't want free GFA when you're going to build your shopping mall, your shopping center or whatever? So this is where the government has actively promoted the underground and allowed these things to be built for free in terms of the allocation of the space and the taxes and charges that are placed on those developments. So civil defense is another aspect that is done in many cities around the world, and not only China, but also in Singapore and other major cities. An interesting one that's been studied quite a few times is in Japan. And you can see here, this is over the years, this is the metro systems that are shown in these circles. And as the metro systems are getting more recent, you can see that they're starting to go deeper and deeper and deeper. And that's because the overlapping congestion of all of these individual rail networks that then are pushing it further and deeper down. So these cities, Tokyo, Osaka, Kobe, and Nagoya, have all tried to tackle this problem by looking at some sort of incentives and some sort of layering and some sort of definition of the legal aspect of ownership. So they have enacted in 2001 a law that says that you can own down to 40 meters the land underneath your private lot, or where you have foundations that extend down to some bearing stratum, that you have another 10 meters below that bearing stratum. And that was to try to look at how the underground can be more easily managed and developments and infrastructure put in place without having too much trouble. So this is one of the examples that you know, is sort of similar in some ways to what has been done in the Philippines. So here, this is the example from Tokyo. So again, we have the same sort of theme of depth planning. So in Tokyo, there's the shallow underground, but there's also the above ground. So there's at the sort of podium level interchange of free flow movement of people, but they also integrate it with how that people move into the shallow underground and into the deep underground or the very deep underground. So again, a similar sort of system that they've developed in Tokyo to other cities in the world. And in one particular place in Marunouchi, there was an opportunity a few years ago where the major landowners there, who was Mitsubishi, they got together. So the private sector got together and worked with East Japan or East Tokyo Railway to put together a plan to create an underground integrated network for people to circulate off of the Tokyo station. So they put this committee together. They then organized themselves to create a set of defined guidelines and rules over how you connect, how you will provide air conditioning, how you provide electricity, who provides what. So there's a set of rules that were put together, and it's a PPP type partnership where they try to integrate this for the benefit of the users in the area and the public. So this was an integrated scheme where there was certain types of connectivity considered. So there was connections through roads and connections through buildings, and then access rights would be provided either through the building or along the road into the building. So there's different types of connectivity that have been considered in this plan. And one of the big drivers of this in Japan at the time was a GFA exemption on retail or underground retail, which drove a lot of that actually. So you can see there in the chart the underground pedestrian networks and so on, and retail shops that were being promoted in Japan. So again, this was a concerted effort to connect different buildings, different places together between the public and the private sector, which was quite successful. So they did a set of classifications of the different types of underground networks that they had. So all of this was managed throughout this particular area to connect between the railway stations and various buildings. So Singapore also has a sort of recently done another land ownership Act, where they have put together a definition of how deep ownership occurs. So they've defined it as a 70 meters reduced level. So this is a datum over which you don't own the land, right? Or you have to request a right to use below that level because the building needs the deep foundations. So this is a act that was put in place in March 2015 to try to control the underground for the public sector uses, and to allow further development to occur underground below existing buildings. One of those examples was here, and this was quite an interesting example because it was down Orchard Road, where the government were trying to promote more interconnectivity between the metro stations and also the retail shops there. So they were offering cashback incentives for the private lot owners and the private developers to connect each other. So this was one way that they tried to incentivize to do connections at basement levels and have a greater improvement or improvement in the usage of the underground along Orchard Road. And then in up to about 2019, Singapore were studying this underground master plan. So Arup were involved in this, and we were involved in looking at the different uses and so on. And again, the same theme again is about how the layering goes and what different types of uses that you would be able to have in different portions of the ground. So on the right there, you can see the different sort of conceptual ideas of where things would lie in terms of the depth in the underground. And they were thinking about caverns, so rock caverns that they would be putting in place, but these were quite deep. And there was definitely concerns about how deep you would want to have people occupying some of these spaces. Typically they're looking at, but they're really looking at the more shallower areas because some of the rock is really quite deep in Singapore. But they implemented quite a few sort of common service tunnels, so utility tunnels. This was quite common in the sort of reclamation areas. So down at Marina Bay, there's some utility tunnels there that service these development areas. So in the master plan, so the underground master plan links itself with the above ground master plan as well. And they're looking at the future of how this then can be expanded around the city. And in particular, they're looking at the data aspect of it. So they're trying to build 3D geological models. They're asking developers and the infrastructure to provide BIM models and 3D models of all of the as-built details. So they're building this database of the geology, the ground conditions, to allow them to understand what's in the ground and be able to control and be able to better manage how the future underground networks are then implemented. So an interesting one in Malaysia was when they were looking at the metro and the MRT in Kuala Lumpur. They didn't have any ownership rules, so there was an interesting concept where they asked people under the right of way to surrender and re-alienate their premises. So the owners would give the land back to the government. The government would then change the titles and the conditions of sale and the conditions of title, so that they could then reoccupy the land underneath it. So there was some compensation given, but this was a way that they did this sort of provisioning to allow the metro to go underneath their lots, because they didn't have a law in place at that time of when they were doing it. So Helsinki is another good example. This is probably one of the few places in the world where there's a statutory master plan for the underground. So this is one of the first cities that actually pulled together one, which then try to preserve and plan and future predict what other things would need to be built in the future. So they used it to not only do underground planning now, but they were reserving places and had resource areas that would then be used later in the future. And this is now promulgated as a legal document. An interesting thing for this was that they had provisions in here for areas that could be reused or were not allocated for anything, but they would then be places that could be utilized by the private sector or others to have some underground uses. Typically, these were for rock caverns, because in Helsinki, the rock is quite shallow. So here, for example, you can see, the law at the time stated that you only had the right to use it down to 6 meters depth from your property, but you could extend down to rock if you needed to do that. And so that was the legal basis of the underground in Helsinki. So they've started to set up, or they have set up, a 3D cadastral system. So all of these underground spaces are mapped now in GIS, and they're mapped as a set of objects and three-dimensional objects that then can define what the underground space looks like, and what is there, and what is reserved, and what is available for other uses. Another one that was quite interesting was Montreal. So Montreal has a huge network of underground spaces, or underground pedestrian networks that are connected to various developments. And the approach here, and this was really through a redevelopment of one particular area. So the city bought up a large part of some downtown areas to do a redevelopment. And when they did that, they had this great idea in the 60s and 70s to allow people to have access through private developments. So the driver for this to become such a successful connectivity or connected underground network was that when private developers bought their land, they had a duty of care and a duty to allow access to the developer who's behind it. So when the metro station was put in, the first guy would then connect to the metro station, and then the guy who's slightly further away has the right to connect through the other private developer, right? So in this way, it was easy to connect because there was an intrinsic right that the developer that's further away from the station could get the right to connect, and there was rules set in place in terms of times of opening and how that then would then the access rights would be provided through each of these developments. So this is one of the success stories, and I think personally, I think it was a great sort of visionary idea that they had at the beginning to create these networks, and which have been quite successful. So yeah, so in Montreal, their initial provisions were to look at the depth of 10 meters, so you own it to 10 meters depth, and below that, the government owned the land below that. So current land and legal framework in Manila. So, in comparison with what other cities have done, I think Manila is just at the infancy of what it's trying to do. We have through MMDA, through the LGUs and regional development councils, various plans and land use plans that are applicable. But I think they don't really go into much detail about how the overall planning will be done, either at it's only really at general land use levels and not specific land use levels. So there was in 2016, there was some legislation put forward, RA 10752, which limited the depth of the ownership to 50 meters below a private property. But this is only for national government projects that are ongoing, or projects that a BOT, build, operate, transfer type project would be operating, and a concessionaire would build it. and then they would have a right to go below 50 meters. But if they went within 50 meters, you would have to then go and ask for permission, or you get your usual sort of expropriation type of aspects of right of way for that. And we've seen already that when you're looking about actually access to the ground, 50 meters below ground is really quite deep and not so easy in terms of usability, in terms of stations and connectivity and so on. So as I say, this law applies, and it applies to infrastructure such as subways, tunnels, underpasses, and so on, floodways, and so on. It's okay in hilly terrain, maybe when you want to go through a hillside or whatever, but if you're trying to get it into an area, say for example like BGC or others, then it's quite difficult if it's 50 meters down to avoid anything, especially when there's so many existing basements. So in terms of other aspects of acquiring land, obviously the expropriation of land, and in the act that was in 2016, it also has the market value and compensation requirements also embedded in it, which actually has helped quite a lot, I think, in terms of right-of-way acquisition, but it's still, as I'm sure you guys know, is really a bit of a nightmare in the Philippines. And then when it comes to mining and the mineral rights, there's in 1995 there was an act that stated that and maybe it's a bit of a contradiction, because actually it's areas close to mining applications. So in terms of mining underneath, you're not allowed to mine underneath public or private buildings, cemeteries, and archaeological historic sites, etc. And also interestingly, there's another law in 2001 that sort of preserves national caves and cave resources, which is promulgated and managed by DNR. So, as I say, I'm not. Maybe this is not exhaustive, and it's not. But this is the legal aspect of what I've been aware of. But maybe there are some things that I've missed. But this is where I think we are in terms of the legal aspect of land ownership in the Philippines. And as we know, there is generally quite easy to build the basements in some of the Guadalupe Formation. I think we all know that. You can excavate down, put rock anchors in or soil nails to support the ground around them. But I already know of at least two properties or two buildings where there's been problems because the underground has got temporary anchors and permanent anchors put in place, and actually now the tunnels and the other schemes that were going to be built may not be that easy, or may be unfeasible because of temporary works that are left in that go outside the property line. So we should be very careful about where these things are, because actually some of this is starting to sterilize the underground, and in the future it's going to be more difficult when we come to try to do tunnels and other underground schemes adjacent to these or through these zones where the temporary works have been put in place. So in conclusion, I think that there's a great opportunity in the Philippines to pull together a master plan, especially for Metro Manila. We're at the infancy of the metro systems and stations to be put in place. And if there was a chance to have a coordinated master plan to try to better manage and connect through to the different stations and facilities, that would be fantastic. There is a demand for many types of other types of infrastructure, such as water mains, sewage mains, and so on. And I think we need to have it integrated into a coordinated underground master plan. And then similarly to what's been done in other cities around the world, this concept of having a land registry with a 3D cadastral systems that then allow you to better manage and better define your underground is something that is a missed opportunity. So I think we should be starting to think about that in terms of implementing it in Manila, if not in the Philippines. And then obviously other cities have looked at developing and managing digital databases of the ground, the geology, and so on, to allow people to more safely develop and excavate and build underground structures and infrastructure. So I think with that's my my presentation, and I hope it's given you some insight into what other cities have done, and hopefully, you know, I would like to think that we could get MMDA to try to think about doing a master plan for the city. Thank you very much.
Thank you very much for that very interesting presentation, Mr. Wallace. Indeed, properly planning out underground developments for the future is definitely key for Manila to progress properly. For the next part of the program, we will be entertaining questions from the attendees. So we have one question here. What is the risk for underground structures with the Philippines being in the ring of fire and prone to typhoons and earthquakes?
What's the risk? Well, yeah, obviously, you know, there's a risk from earthquakes, obviously. So, we know that the West Valley Fault, Marikina Fault runs through the city. So, actually going across active faults is not really a good idea from a tunneling perspective. But what has been definitely noted from places like Tokyo, that actually underground spaces are more resilient when it comes to earthquakes. And actually, because of the confinement, they're generally quite robust, and they generally perform well when it comes to earthquakes, as long as they don't cross active faults. And that's an issue, making sure that when you're looking at these, that you don't actually do that. In terms of flooding and so on, obviously there are, you need to do proper studies to make sure that the tunnels and the underground space are actually away from these places. And you have proper provisions for access, and the portals and so on are protected from flood risks. So yeah. Is that a good answer?
Mark, thank you very much for a very, very interesting presentation. Question, because I mean, we all know about records here in the Philippines. And to me, the biggest worry in implementing tunneling projects here would be the unexpected change in construction, which is not properly recorded. I mean, when you did the Nova Bala project, did you have any surprises on that tunnel?
Surprises? Surprises. The thing about
that you encountered structures or things which shouldn't have been there.
No, well, we didn't encounter anything as far as I know in terms of man-made objects or physical obstructions, right? So there was obviously some groundwater, some issues in some places where there needed to be some control, which was fine. And that was managed quite well. And we even drove the tunnel very close to one of the foundations of the MRT, and actually with no movement, no problems at all. But there were certainly some issues in terms of a few locations, and this is where you look at, when you're looking at geology, you're looking at the type of ground that you're going through, right? So what you see now is what you got in the past, right? So you get these incised gullies and these rivers that are currently going around through Manila, and you have some of them that were in the past. So when they've been filled over by the volcanic eruptions, you have these sort of incised pockets of gravel and other types of materials. So there were certainly some times when the TBMs were going through some ground conditions where there were mixed ground that seemed to be like that there were some issues of progress and so on, and water inflows. They were manageable, and there was no real any issues, but there was a change in geology that then had a different impact on the performance of the the tunnel. But these were not unsurmountable problems, but these were just changes in lateral condition of the ground. So I think, yeah, but we didn't. I don't think we encountered any obstructions. I can't remember any.
Okay, thank you. Well, it's going to be interesting if the underground construction will find some, especially in the McCarthy area. They're going to be very interesting.
Well, as I say, I know at least 2 developments where there's issues of things that are left in the ground. So those are potentially issues that we need to address in the future. How to tunnel through existing steel. It's been done in Hong Kong. They've tunneled and found steel H piles and so on. And it really, if it's a big H pile, the machine has to stop, and people have to get in the front of the TBM and cut out the steel. It's really dangerous work. It's not easy. So yeah, to be avoided if you can, Thomas.
Okay, any further questions?
We have a few more questions. So here, in some jurisdictions, underground construction has been delayed by archaeological finds. For example, the Crossrail in London. Is this an issue in Manila, and what are the contractor's responsibilities?
Yeah, that is quite common. That it's quite often that's happened. It's even happened in Hong Kong where they found an old well and it stopped. Typically it's on stations where that occurs. In Egypt, they've tunneled through old burial caves and so on, and bones have come into the TBM. So there are places where it has happened, and sometimes it's because these things are unrecorded. But typically, you should, in theory, do a historical sort of archaeological investigation of the site before you do the project, and any artifacts should be properly managed in terms of, if they're found, they should be then preserved or considered. But you should be doing those investigations as part of the EIA anyway, in the first stage. But yeah, there's always the unexpected that can crop up, and so yeah, it's a risk.
Okay, thanks, Mark. It's now over almost 6:10 p.m. So we'll take a few more questions before we have to end. So here's another question. What are the potential barriers to a centralized transport planning strategy in Metro Manila?
Yes. Well, there you go. That's it's coordination. There are obviously we need to have when transport networks work best is when they interchange well and when they can be connected better, right? So that, and then it's this an ease of transfer between one system and another. And actually that's what we should all be trying to achieve when we look at centralized transport planning strategies. We should be looking at how we actually get people to transfer and move from one railway to another railway, and really is having a proper steering committee or a proper management of that, and a plan. Really, it's having a proper plan, in my opinion, to really set out exactly how that then needs to be implemented, and unfortunately not to have too much change through government, political changes and so on, so that actually you can, when you're investing in a long-term plan, you should be committed to the long-term plan, in my opinion. So the change in politics is a problem, and the change in our right-of-way issues and ownership is a problem. So it is quite difficult in the Philippines and in Manila, I think, but you have to, the end result is worthwhile, and the pain is worthwhile to get to that point in the end, to be honest.
Okay, thanks, Mark. And for the last question, the technical one, how is the best way to dig Guadalupe Formation in your opinion? EPB, TBM, slurry TBM, or can we dig it fast with a double shield?
Oh, well, we NBA Q4, we use an EPB machine. So it really does depend on what type of ground conditions, but you know, we've been quite successful with an EPB. And you know, even with controlling some of the groundwater, it's been generally okay. So you know, if really groundwater was a bigger issue, or you have more soft ground, then maybe a slurry machine would be good. But I think both would probably work reasonably well in the Guadalupe formation. Even mine tunneling that we've done, we've done quite small mine tunneling, has been generally stable. So I think most type of tunneling in the Guadalupe is generally okay, I would say. EPB probably preferred, slurry just as good as the EPB probably. Okay, so any more questions, Lance? Is that, I think we're out of time almost, so I think people want to go to have a beer or go home. So I think everybody, thanks for listening to me, and I think that we normally you know, have a some sessions that we're going to try to organize in January, February, March next year. So we're going to organize more of these talks, and really the intent is to try to get back to having the face-to-face meetings in the Elks Club and so on. So we will try to get back to normal if we can. And you know, we'll still be posting the newsletters, and please provide information to us if you can on anything that's you think that you can share with the membership. So I think that's really all I would like to say. I think, Lance, you want to do a picture taking for the final thing?
Hi everyone. Yes, so you should be seeing a prompt on your screen soon to open your cameras. So let's wait a few more minutes for everyone to join us here in the room.
So could you want to open up your videos so we can see everybody, and you know, be nice to see you guys.
Seeing a few people join in. Let's wait for the others to join the room.
Hi, Lance. I can't seem to open my video.
Thanks
When
for
I-
that. Oh, sure.
Same for me as well, yeah.
Oh,
Let me open it for you, Israel, and I'll come. Waiting for a few more of the attendees to join in soon.
come on, guys, don't be shy.
Hi, everyone in the room. So please turn on your cameras. Or I think a few more people are joining in.
Come on, Roger. Get your you know, let's see you.
Okay, we'll be taking the picture soon. You'll see a few more people joining in. Yeah. So let's take a few shots. Okay. Please hold your smile for a few seconds. Okay, everyone. Yes. Okay, let's take a picture. 3, 2, 1, smile.
Yeah, not too much though. Don't smile too much, guys. Go on.
Okay, let's take one more shot. Okay. 3, 2. Sorry, one more. 3, 2, 1, smile. Okay, there we got it.
All right. Thanks, guys. Thank you, and hopefully we'll send out the notice for the next presentation and meeting for January soon. Okay.
Okay.
And,
Thanks, Mark. Very good.
Yeah. Merry Christmas, everybody.
Merry Christmas.
Is it Merry Christmas?
Merry
Yeah, I
Christmas.
think so. It's Merry Christmas. All right. Sometime soon. All right. Good to see you,
Bye.
Roger.